Hello folks, today we are going to see projectile motion. It's like a particle moves in a vertical plane with some initial velocity, VO, but its acceleration is always the free fall acceleration, G, which is downward. Such a particle is called projectile, meaning that it is projected or launched, and its motion is called projection motion. The idea is analyze it using the initial velocity Vox and Voy using the vector ideas, but we can find the components of Vox, multiply for cosinus and for sinus to Voy. So let's go to see how it works. All the thing pass as we have the constant velocity in the horizontal motion, and in vertical motion is like a free fall. So we put these two movements together, we have each kind of motion. It means we have a constant velocity. Here we can see this vector Vx, it's the same size. We have the same velocity is constant, this vector here, and we have here during up and down the velocity at the Vy change. So we have here a velocity O because it's up, stop and start to fall here. So we have this kind of motion here. Okay, let's go to see the formulas to it. So we have here the horizontal motion. So we have these two formulas that are to velocity constant. In the vertical motion, you use this formula that you saw in another videos here, and you use this both to solve some problems. Let's go to see a solved example. So we have here during a free works display, a shell is shot in the air with an initial speed of 17 meters per second at an angle of 75 above the horizontal, as is illustrated in figure. So we have here this figure. The fuse is timed to ignite the shell just as it reaches its highest point above the ground. Okay, let's go to do the first, the letter A. Calculate the height at which the shell explodes. So when the shell explodes, we have the velocity O because it will stop to fall. Okay, so we will use this formula, and Vy squared is O. Okay, the final velocity is O. So you use it to isolate the Y here and to find the height here. So you need to use the velocity Voy because you are analyzing this fall. So we don't using here the constant velocity. So you use here the idea of fall. So we find Y equal 233 meters. Okay, let's go to see the letter B. The letter B is how much time passed between the launch and the shell and the explosion, the letter B. And what is the horizontal displacement? The horizontal displacement will be with a constant velocity. Okay, let's go to see here in the letter B. We have this idea of formula and find 6.90 seconds. We will find here the displacement in x. So we will find here and we will find here using cosinus and 18.1 meters per second, and we have 125 meters in x. So we have this figure here again showing to us that we have 233 meters, and x we have 125 meters. So let's go to see this problem. Now you can choose stop it here and do the exercise. So I will solve it now. The letter E, this calculate the time it takes to, the rook to fall on this path. So you will use this formula. We have YO is O, okay, and we use here to find the VOY using sinus. So we have here this system, and you need to solve it. You will call the letter A, B, and C like this here, and we will use this formula to find the 2 times here. So let's go to the letter C. The letter C is the letter B. What are the magnitude and direction of the rook's velocity at impact? So we have here using Vx, Vo cosinus, and we will find here using this second time. Here is the time that it takes to reach this position. So we will use here the 2 velocities to find the letter B. That is, we have here what are the magnitude. The magnitude, you will always use this idea of V squared x plus V y squared, and you will use the square root here of these velocities to find this value.